everywhere on the internet. I'm a principal software engineer at Puppet, basically working on all sorts of different software to help people automate infrastructure. I'm touching on bits of that, but mainly I'm going to talk about security here. So various things. So, rough rundown of what I'm going to talk about is sort of a little bit of context. I think for this audience, it's sort of probably like not too controversial, but like really around the end of sort of perimeter-only security. I want to talk about the movement of a whole range of different, I guess, features and functionality from what would have traditionally been infrastructure or middleware or someone else's problem to being fundamentally part of the application, being a first-class citizen within like the domain of the application. I want to talk about the sort of the rise of the black box application in terms of the move towards containers and serverless and these other things. And to a degree, the slightly odd obsession with talking about the platform as if that's going to solve all the problems, when actually a lot of the problems, both security and otherwise, are actually still in the application, and the application is now a black box. And I'm going to talk through some examples of actually what we can do about that sort of those problems. Pushing security concerns down to the application and away from sort of that idea of adding something on top. So hopefully that's interesting, and no one's leaving, so that's fine. So kicking off, and again, really just sort of setting the scene for why some of these things I think are going to be increasingly important. So, nice quote from one of my friends, from James Wickett from Signal Sciences. For much of network security, firewalls were the answer. Got a security problem? Throw firewalls at it. Like, got another security problem? Add another firewall. Maybe this time it's a proxy or a load balancer, or it's basically a box in front. That was always the answer. Like buying that appliance. Like, it's really just an example of that sort of like that common sort of truism in software development of like, any problem can be solved with another layer of abstraction. And over time, you end up with that network diagram that's like, it's like the thing that's actually important, the application, the thing that's making you money, is sort of like going through this large chain of somewhat crazy sort of middleware. But it makes sense in context. It makes sense in like why and when it was done. Because actually, adding something new on top was often much quicker than fixing and releasing the software. And going back further enough that like you could probably add something in front reasonably quickly, and even down to sort of provisioning hardware, when actually releasing the software might be, oh, that's risky. That's going to take a long time. We only do that once every 6 months, and we have to switch everything off at the same time to do it. Oof, you don't want to do that at the moment. And like the list of things we need to work on is long, and like, well, do we add that? Like in that setting, in that context, just adding something on top makes perfect sense. But things are changing or have changed. And with modern software approaches, we can actually totally change that software quickly. And going back sort of like to sort of the sort of seminal presentation by John and Paul at Velocity, 10 deploys per day. Like at the time, everyone was like, whoa, no way. And now that's actually, it's like, well, yeah, lots of people do this. It's like we have patterns and practices and tools that help us sort of do that. The interesting things there are sort of really, to me now, are 10, sort of only 10. And also 2009, this is not necessarily that new anymore. These things are possible and well documented and done at scale. The sort of the arguments for not starting to do these things, at least heading towards being able to do those things, are increasingly slim, I think. And you sort of go to sort of full gamut, and even this is 2011, when Amazon were like, oh yeah, we sort of do that as well, where they're like, we deploy every about 11 seconds. And you're thinking like, that's unreasonable. What's really unreasonable is like, what do you think that number is now, sort of 6 years later? It's like sort of frightening. for those that are not sort of familiar with the sort of that practice, all those patterns, like how to do this well, and the banner of sort of knowledge that sort of like encompasses it really, like continuous delivery tends to be the words people have used to describe it. And this is the sort of classic book from Jez, who got name dropped in the previous talk as well. Like well worth reading. Like we know how to do this. We have words, we have things, like we can release software quickly. The interesting part there, coming back to, well, adding those bits in front, is maybe we don't need to keep adding things in front now. We can actually fix or push some of that functionality into the applications. It's interesting to note, sort of, this is a quote from the Google Infrastructure Security Design overview, like them describing how they do this. We do not rely on internal network segmentation or firewalling as our primary security mechanism. Note that it's not saying like, we don't do any of that. It's just that that's not the primary, that's not the be all and end all. If it is, you're probably doing it wrong. Some of that is around attacks that are increasingly targeting application and business logic. It's not just the network that's going to protect you. You need to be smarter. You need to be nearer the application. So with that context, well, where does security go? Stepping slightly away from security, I think there are other things we can look at for sort of to tell us what might happen and what we'll probably need to do. So there's all sorts of other things that I think are going through this same sort of like being affected by these same forces. The ability to change software quickly has seen all sorts of things move from being middleware and infrastructure and someone else's problem and a different department and a different team towards being fundamentally part of that application, like being a first-class citizen. I think health checks are a really good example of this. At one point, well, applications were just sort of running and someone else somewhere would write some explicit monitoring checks within a separate monitoring system. And all of the sort of the knowledge of like, what does healthy mean was separate from the application. It was someone else's to discern, probably after it had shipped, and possibly even after the development team had gone away on holiday or whatever. Like, what did health mean? And increasingly you see the way that embedded in development frameworks and individual applications, these sorts of, like, whether it's an HTTP health check, whether it's some sort of other type of application, a way of saying, just a standard way of saying, tell me if you're healthy, and tell me details about your health. You see the same sorts of things for metrics. And again, this is one of those things that was often second class, done later, someone else's job, trying to discern like tea leaves. Instead, we're increasingly embedding like the metrics into the application. Well, what should be instrumented? What should be exposed? So the work of collecting those, you still probably have a monitoring system or some sort of metric system collecting the information. But now all of the knowledge about, well, what to collect and where to collect it from, the business logic is in the application. Logging, I think, is important for a whole bunch of use cases. And the sort of the growth of structured logging, and logging as a first-class citizen. No longer is it really good enough, I think, to just simply, we output a load of arbitrary strings and syslog will deal with it all. Like discerning what these things mean is sort of not often clear. Towards something that actually you're thinking explicitly about. You're using some sort of known good structure, some semantics for your logs, and doing that in a standard way. We're seeing all these things, again, like move to the application. It's not just, it's a log file that comes off the web server that the application was running in, like massively at a distance. It's no, the application is emitting structured logs. There's all sorts of other examples as well. And from sort of manual black box testing done by someone else somewhere else to, like unit tests, acceptance tests, like code in the repository with the application code, testing that code. We're moving those things towards the application. From configuration files to sort of injecting things via environment variables or using a configuration store of some type. From like static configuration to sort of service discovery. A lot of this is sort of encapsulated for those that haven't seen it in the 12-factor app. And as a list of these 12 factors that are sort of like building your applications like this leads to certain portability sort of like goals. It's definitely, if you're not aware of it, well worth reading. But from the sort of this narrative from the history, sort of like, a lot of these are about things like making that interface clear, moving some things that were maybe, again, someone else's problem towards being part of the application. Now we can move the application quickly. So, like, that's what I think is happening. That's where I think security will ultimately go. But it leaves us, in some cases, in a sort of a middle ground at the moment. We're not there yet. Not everyone is doing all of these things yet, either for operational concerns and certainly not for security concerns. But we are driving towards, I guess, platforms. I would be surprised if sort of people working in many organizations, there's not someone or some team or something driving. We have all these applications. We want to run them all in a standard way. We have to have some sort of platform. Everyone wants a platform, whether they know what they want it to do or not. Everyone has sort of a platform strategy, and that platform might be, and it might be looking at things like containers and Docker and Kubernetes. It might be looking at things like serverless and Lambda, Azure functions. People might have been using Heroku or Cloud Foundry, or even just building a top sort of like public cloud-based virtual infrastructure, or even like within your data center having a standard way of doing things on top of VMware or whatever it might be. But it's all about that standard, that way of like, oh no, everything runs on the platform. From a security perspective, I think this is really good. Like, no more just completely different ad hoc ways of doing things that all require individual effort. We can get security features into those platforms, especially with a number of them being open source. A lot of the conversations are very public. It's easy to engage from a certain point of view. There are special interest groups around security for most of the sort of core open source platforms. And the conversations have been going on for a long time. Like, we're adding really good security features into those platforms that everyone who uses them gets for free. That feels like a big win, rather than going through your organization's like many generations of ad hoc ways of running applications, fixing the same problems, but fundamentally in a different way. If we can have a platform, you can fix it once for everyone. That's got to be a good thing. But I think there are some downsides to the sort of the fact that platforms are the new hot thing. It sort of you end up going like, well, oh, my platform solves all my problems. I think how I've sort of been just like talking about this a little bit is the platform works from an operational point of view, from a running an application point of view, by not caring about the details of the application. It gives you, from its point of view, a perfect abstraction to run anything, but it doesn't know anything about your applications. It's a black box. From the point of view of the platform, your applications, there are many black boxes. And I know that one's more important maybe, and I know that one requires like memory, and this one needs to run on machines that look like this. But they're not really about the application as much as just simply running it. I think you see that in terms of that, like those black boxes being, it might be serverless functions, they might be containers, they might be virtual machines. I mean, like lots of organizations are using that sort of, our output from our build pipeline is a VM, and we run many of those. We've got that separation. That's our platform substrate. That's our black box. I think from a security perspective, like, that worries me. Like, especially if you couple it with, oh no, the platform solves all security problems. We don't need to do anything else. And then you go, well, the platform knows nothing about the application. It's a black box. And people are like, Like, that disconnect is sort of, I guess, the core of my talk. And what I'll come on, hopefully, talking about some of the things we can do. I gave a talk about like a very deep dive into sort of what's inside containers. I think containers are increasingly that unit of software that I sort of talked about in the title. I mean, check out that if people are really interested in a lot of the details. I'll skim some of the research here. Because there is that, well, what's inside your black box? What's inside that container? And often, and like that's sort of made out in this post, like you don't know. And to me, I agree that this is a problem. So the talk I just referenced with a whole bunch of research around actually, well, what's real world usage of Docker containers? Because there's a sort of there's an ideal and there's the reality. The reality is most people are embedding the operating systems inside, like user space, inside their container file systems. So whether it's Alpine or BusyBox or actually Ubuntu and CentOS, and actually we're just taking all the stuff we had outside and putting it inside, but not always with the same level of care and tooling and understanding that we had previously from the sort of more systems administration mindset. Like the sort of like the tiny immutable single binary process sort of Google Scratch container type model is actually really uncommon. And that's often where a bunch of the platform security features assume. And that big bit of file system stuff can lead to all sorts of issues. Because you end up going like, well, wait a minute, that's an awful lot of stuff. So given that that's the most common usage for software, like for Docker containers, you end up going like, well, actually, if you're using like the Ubuntu one, that's 98 software packages, each are independent versions that you're probably not aware of, able to ask about or actually actively managing. Any of those could have a known or unknown software vulnerability. And in fact, there's been a number of cases of people doing not always great research because it makes a good title. So there's sort of caveats with a bunch of these things. But there are absolutely like images that people will be using as a core part of their sort of workflow from third parties and from first parties. I think the first party stuff is more interesting and important. Like with known vulnerabilities that people don't have a good way of actually ascertaining. So most containers have an operating system user space. Most containers have lots of unmanaged stuff. Many containers are not run in a mutable manner, and some of them have vulnerabilities. But the platform is like, it's black box. So that's someone else's problem. Serverless is sort of another paradigm that brings other interesting security challenges with a sort of similar theme. And this from sort of a guy from SNCC. Like, these code packages are like little pieces of infrastructure embedded inside your application. It's like, see, it's like serverless, you don't need infrastructure. It's like, no, you've moved a bunch of it into your application. You now need to treat it in the same way and care about it in the same sort of way. These things, and this was this from Guy as well, but I think really is a good summary of a whole bunch of this sort of move towards platforms. There are loads of good things about platform security, like bringing that to a single place, doing it well. Application security is basically still the same set of problems. We haven't improved or like made it worse. It's just pretty much the same. But this is where we get to sort of the last bit, really. Existing approaches to how we've done security don't always work. We're in a world where the platforms and the software development has moved faster than the security tooling around it. So what can we do? And ultimately, we need to push security concerns to the application. In this new world, we need to push everything that we've sort of encapsulated in separate tools for security people into middleware. We need to push it into the software application developers' hands. And one sort of pattern is pushing security testing into build time. And we heard some mention of this in the keynote. And there's a load of tools that actually facilitate this. OWASP app, I think lots of people here are probably familiar with. There's probably some people who are working on this. And this is a great tool to do this sort of thing. BDD security is another really interesting tool. I'll fly through some of these, but the slides will be available later. Linus as well is sort of one I've been using recently to do security testing during the build of virtual machines, and works really well. If it spots a security problem, the image is not built and it's not passed on to the next pipeline. It's a really nice sanity check. Another sort of pattern is really getting good about assuring dependencies. Software development now is invariably not, I wrote everything from scratch. It's, I downloaded 2 gig of software from the internet and integrated it together, and wow, I can write things faster. But we need to get good at assuring those dependencies don't have known vulnerabilities. Another tool from OWASP for the sort of Java-minded folks, dependency check. There's also a similar bundler audit for Ruby. There's similar tools for other environments as well. Guy, who I mentioned earlier, works for SNCC, and they do a really good tool for assuring dependencies in JavaScript, and I think a few other languages now as well. And we need to take a bunch of this and apply it to, it's not good enough to just to think about that in terms of the application. We need to think about it in terms of the black box that's delivered to our production environment. Because often there's a gap between the application and its infrastructure. If we're bundling those things together into a black box, we need to assure the black box, not just the code that went into part of making it. We need to push a bunch of testing into production, because the only source of truth is the network. Like ultimately, at the end of the day, it's not like the thing that gets like compromised is the running application. I think I'm a massive fan of CMDBs done right, the sort of configuration management databases. Like done right and kept up to date, they have loads of data that is really interesting and relevant to build like query tools over the top of. So Puppet has a bit that does this as a sort of a byproduct of how it works. And I've done a whole bunch of like writing assertions against that data for security purposes. Being able to say very quickly, like, and make up these queries is really interesting. I'm also a Lisp nerd, so you don't have to use Lisp. And doing some recent work around actually building test suites around Docker containers. So you can make assertions, make policy assertions, both as part of build, but also in production. Like you have policies, are they being followed? Are people actually doing these things? Let's write software tests to make sure they are, because like the feedback cycles can be faster, and also people are sometimes resistant to being told things by people, but actually when you can blame the computer, it sort of gives you an avenue in, because you can go in to help them fix the problem, not be just the person carrying the bad news. And building visibility into applications. We saw the monitoring and metrics and health check type things. What would some of those things look like for the types of questions security professionals want to ask? I think OS query is an interesting way of sort of looking at this. Basically, SQL for your entire system. Just write SQL queries and query those things. You need to put the things there. What types of questions would we ask as security professionals if we could ask anything? Let's get that into the applications. And again, like CMDBs actually provide another hook for this sort of thing. Collect all that data in one place from the applications and query it in one go. Fundamentally, we need to let the runtime protect us as well. There's quite a bit of talk. I've seen less actual real like implementation stuff and less open source work around this. But like the idea of RASP, runtime application self-protection, comes into play when the application is executed, causing the program to monitor itself and detect malicious input and behavior. Doing these things in real time in the application, not after the fact, I think is sort of super interesting. Another OWASP project, AppSecEU, is doing a whole bunch of stuff in this space, and it's sort of interesting to have a look at for folks. I'll skim this quickly. So, in conclusion, I think, again, like for this audience, it's like, duh, but we need to secure the applications, not just the platforms. I think when you sort of go back out there, like talk to all the people who are getting hot about platforms, whatever they might be, Kubernetes or Docker or anything else. This is definitely the direction of travel. This is definitely a good thing, but we need to engage and say, all right, like platforms don't solve all the security problems. Stop saying that. Ultimately, developers are conquering the world. And if folks haven't read this sort of short book by Stephen O'Grady, The New Kingmakers, it's worth doing. A lot of this comes down to driving forces that are going to drive us towards this sort of platform and like sort of black box future. How do we make that a secure future is sort of a good question. I've talked about pushing security into the CI pipeline, providing assurance of dependencies, building visibility into applications, getting reactive security into the runtimes. I think these are all good things we need to do. There are definitely other things we need to do as well. I think fundamentally as well, we need to move away from building security tools for security people and push these capabilities down into the development tools, push security features down to like the frameworks and tools that are being used elsewhere, not, oh, it's something else to add on top. We can move software faster today than ever before. That means we can get security into the right places, not just as a band-aid afterwards. Okay, so I'll be around the conference for the next few days if folks have got questions, and that's me. Thank you very much.